Hi. Welcome back. Should I teach like this all day? Today we're going to finish up our last section of... See, that would justify falling asleep. Not that regular physics stuff doesn't. Cool. All right. Last night we looked at 6.3 and you guys had that worksheet. I'll come around and check here in a second just to see that you've tried stuff. As we go through here, today is going to have a lot of work time, which is perfect because it means that once we, finish up everything, we'll be able to just watch the game as you work through stuff. So, yesterday I asked you on 6.3, which we're dealing with relative velocities, I asked you to do number 3 and try number 4. On number 3 on that worksheet, as we looked at it, I'm not going to list out the knowns and stuff. If you've done the assignment, awesome. If you haven't done it yet, less awesome. But I'm not going to show you all of it. I'm going to give the answers real quick. If you've not done the work to get it, it'll give you a nice way to check. If you got the answer wrong, it'll also give you a nice way to look at your work. And then I'm going to ask that we try to find the mistakes. Cool. So, number 3, just so that we have it, we're looking for the velocity of a plane relative to the ground, which is obviously something that is super duper important for pilots, passengers, air traffic controllers, like literally anybody who's involved in the flying process. Okay, looking at it, we have some knowns. I'm not going to list them. We knew the velocity of the plane relative to the air, and we knew the angle, kind of. They said due south. What's that angle if we're going due south? So down is not an angle, but you're right, that's the direction that it is. What's the angle? And you guys said it. 270 is what I would use for that angle. Okay, when you plug and chug through this, what do you get for the velocity of the plane relative to the ground? I hear 194.6. Can I get a second? I think your answer is better than mine. I called it 190 just because of significant figures, but I'm cool with 194.6. 194.6 what? Kilometers per hour. That's not a big plane. It's either landing, but I don't think that's what's going on in the problem. This looks like it would be a Cessna, a small little personal plane that somebody would fly. Okay, at what angle, theta, is this plane flying relative to the ground? So Abigail's holding off. Somebody else has an answer, I think. Does anybody else have an answer? Fern, what'd you get? Yep. Not what I have. I don't have 90. Do you have 90, Abigail? Do you have 90, Rafa? Okay. What do you have, Rafa? Negative 64 degrees. Okay. I am good with this answer. Now, for bearings and stuff, there's some weird ways that it works because the way that we do nautical or ocean bearings is different than the way that we do aviation bearings. Nautical bearings typically start from north or south, and you could even just use degrees if you needed to. With planes, it's always from north, which is kind of odd. Okay, alternative ways to write this. Negative 64 degrees, I'm fine with. Or you can start at east and turn 64 degrees to the south. I'm cool with that. You could start at the south, and you could turn, 26 degrees? To the east? Is that the right number? Yeah, that looks like the right number. Those are the 3 answers that I would expect one to have. If you really wanted to go crazy, you could go 296 degrees as well. These are all the same angle. They're just 4 different ways to write it. Cool. If you got this, awesome. If you didn't and you did the work, I can help you dig through the problem after you've tried during our work time today to find any issues that we might have had. Cool. If you didn't do it, I'm not going to do the whole problem for you. Here's the answers that you can check to see if you're correct with it. Cool. Number 4 was the one that I asked you guys to try with the understanding that it is the hardest problem that we have. Okay. Did anybody in here get a full answer on number 4? Okay, we're going to start number 4 together. I don't know that I want to finish it just with you because I can do these problems, but I'm not testing me. Cool. We're going to start it, getting it set up, making sure we're all on the same page. and then we're going to use a little bit of group work and talking it out to make sure we can get through it. Which means if you didn't do number 3 yet, during work time, when others might be working through like a chapter review stuff, this is what I would suggest you guys work on. Cool. So number 4, let's see here. We have a plane, and it's flying at 285 kilometers per hour relative to the air. There's a wind that's blowing at 95 kilometers per hour at 30 degrees north of east relative to the earth or the ground. And we're asked to say what direction should the plane head and land, or to land at an airport that's due north of its present location. Okay, that's a really important statement. If I want to fly and end up due north, what should my horizontal velocity be? If I don't want to move left or right, it has to be 0. Now, we'll have to work that out and see how we kind of get through it. But let's start this by drawing a nice, at least little motion diagram. So just a reminder, we're looking at number 4. What do you want me to draw first? There is not a right or wrong choice as long as it's one of the choices. That's an odd statement to make. Sorry. Cool. Here's an axis. I don't care which one we're dealing with first. Are we going to draw at least a rough vector to make sense of it? The plane relative... I already lost my spot. Need to read it. Are we going to draw the plane relative to the air or the air relative to the ground first? Air relative to the ground. Cool. So, reading this problem, I'm going to start at the origin because that's where we always start. Which quadrant should I launch into with my vector if it's the air relative to the ground? Quadrant 1. Okay. Now, just to be consistent with it, I'll go ahead and say what's the angle that I need? Just so it's kind of close. 30 degrees. Is it east to north or north of east? North of east. Fantastic. Okay. This is the velocity of the air relative to the ground at theta, air relative to the ground. Now, when I write my knowns out, we know that it's 30 degrees, and that's how I would write it, even though it's given me the bearings, because we're always going to go from what position? Gosh, long wait times are so fun. I've said it over and over. We haven't defined it really. Where do I normally start an angle? East. Positive x, right? Okay, that is in standard position. So always standard position, 30 degrees. Cool. What else do we know? Or what other picture might we be able to draw? And I'm going to do this one really faint, and I'll throw it right there. So somebody that's not Abigail or Rafa or Fern, no offense to you guys, but read the problem. We have another piece of motion that's happening. We have air to the ground. What else is happening in problem 4 if you read through it? One more time. There is wind blowing, and that's what I would call the air relative to the ground. Like you're right, but that's just to make sure that we can clear that up. But there's something else that we're dealing with. We know another speed, I think. One more time. Don't care if you're wrong. The airplane, how fast is the airplane flying? Relative to what? The air. Okay, now, we also have that the plane is flying at 285 kilometers per hour relative to the air. Now, do they specify the angle? They don't specify the angle. So what on earth are we going to do? We don't know it, do we? Now, I can kind of guess at what it's looking like. If I need to end up due north, I think it might be fair that I know what direction I have to fly. If the plane was just flying straight, would the wind push it, you think? Probably. Now, I'm okay with east or west or right or left, whatever. Right now, the wind is blowing what direction? East, northeast, but east, right? In the horizontal. Which means the plane, if it wants to end up due north, what direction should it probably fly? Northwest. Now, reasonably, if you guys stood up and I wanted to push you around a little bit, we could see it. But I think it's reasonable that my plane better be flying somewhere over this way. And its magnitude is much larger than that of the wind because it's going so much faster. Okay, now I can even eyeball this out. Mine isn't perfectly to scale, but I know that this vector right here, if I stop and just let it be here, that's not correct. Because I know that I want my plane to take off and land where compared to where it is, does it say? Due north. If I put this vector all the way over here, and I don't know if this angle's not right, just because I didn't measure anything, but if this is where I end, is this due north of where I am? Right? Like I can see that, hey, look, I'm due north right now. This is the velocity of what? The plane relative to the air in this case, or the wind if you used it. And then this right here, that big angle, is my theta of the plane relative to the air. Everybody cool with that? Now, there's a resultant just waiting to be pulled out here. And the picture, in my mind, I'll tell you, I didn't even draw the picture when I did it. This is my resultant. This is what I know is going to happen in the end. I need to fly due north. Okay, so this picture, if it helps, awesome. If it doesn't, I don't think it's going to hurt. But let's just kind of get through and see if we can't start the problem. I will turn something all the way back up, the brush size. Cool. So let's see, what do we know? And I think that's a little bit too bold for me. Barsega, can you give me one of the things that we have as a known on number 4? The velocity of the plane relative to what? The velocity of the plane relative to the air. What is it? 285 kilometers per hour. Cool. Anything else that I know? The velocity of the, and I'll switch colors so I try to be consistent with it. The velocity of the air relative to the ground would be equal to what? 95. That's a pretty strong wind, but when you're, super high above the ground, that's reasonable. Anything else that I know? The angle. So I like that. I'm going to call it theta. Theta what, Kalisha, are we told? Which angle do we actually know if you read through the problem? So it is 30. You're good. But what I care more about, yep, and that's, thank you, Makisha. 30 is great. That's half the battle. Do we know the angle that the wind is blowing at or the plane is flying at? Wind. So I'm going to call that the air this time. That's the air relative to the ground. And that's 30 degrees. This is all that I know, and it seems like maybe there's an issue with it, but I promise we'll be able to remedy it. What are we trying to find here, Sean? Okay, so when you say the plane relative to the ground, what about the plane relative to the ground? So I need the velocity of the plane relative to the ground. And I'm just going to read this last piece. In which direction should the plane head, and what is the speed? Which means that's me asking for the magnitude of the velocity and the angle of that plane's velocity relative to the ground. Okay, this is what I'm after. Now, there is one other piece that I've drawn up here that we do know that we'll deal with here in a second. As I look at the picture, I'm trying to find this here. Now, looking at it, I'm trying to decide here, do we have, let me check this, relative to the air. Cool. So let's jump in. We need some equations. Now, remember, we're trying to land due north, right? I know that that's where we're trying to land. This vector represents what? This blue one. You're good, love it. And again, I want to stress it doesn't really work like this, but the math makes it look like and feel like it works like this. If you take a/g, that's not a fraction, and p/a, is any part of that going to fall out if you were to multiply if they were fractions? The a falls out, and you'd be left with a p and a g, right? So this is what this represents. That's it. Okay, Now, based on this, I can see where that 90 degrees shows up. If we have it, let's see if it really is what spits out of it. Because maybe our picture's just not perfect, but we trust the mathematics so much more than we trust the picture. Before moving on, any part of this that we look at that you go, ooh, I don't think so, or you're uncomfortable with? Okay, so for this then, I want you guys talk with your groups for just a moment. I know that some of you have tried. Don't just blindly give the answer. Talk with your neighbors, however, and see if we can find some equations that we might be able to use to get through this problem. Talk it out. I'm going to call on somebody random in about 90 seconds. Any and all equations that you might like. All right. So, no wrong or no bad suggestions here. Equations. I liked what I heard Sean say right away, but I'm open to others. Any equations that we might have found? What did we use in all the other problems? Like the other three. There's a few equations that kept showing up over and over. Vx and Vy, we probably calculated those out. Whether we use them first or not, maybe, but let's just write it out. If I wanted Vx, and we're looking at the plane relative to the ground, right? If I wanted to find Vx, how would we do this? Not so rhetorical. If you need to chat it out before, I'm fine with it, but I don't want to just yell at the answer. How would we find Vx based on all the other work that we've done? That's the question at hand. Okay, so we would have to account for some of these things, right? We could take, as we're looking at this, this is with the plane relative to the ground, right? Like this is where I'm trying to figure out where I'm aiming. In this picture, whether or not it's perfect, it's there to help us make sense of it, but don't trust the picture, right? Okay, so if I wanted to find this, we would take something times cosine of something, right? Because we're doing the x direction. The somethings are what I'm after. I want to know what I should physically write down here. So what velocity is what I'm more concerned with? So the velocity of the plane to the air times the cosine of theta plane to the air, right? Plus velocity of the air to the ground. Okay. Times what? Cosine of theta, the air to the ground. Now, before we do anything else here, I'm going to go back to that first little comment that we made. Before I plug and chug through this, what do I know that the x total better be in the end if I want to land due north? Say it again. 0. Does that idea click with everybody, or are you just accepting it as fact? Sorry? Yeah, in the x direction, we better be 0 in the end. Do you understand why that's the case? So check it out. Will you stand up for me? Cool. So this, we're just going to say straight ahead of Kalicia's due north, okay? And I'm going to be the wind, so I'm going to push you a little bit. Your goal is to make sure that you walk due north. Walk straight, okay? So she's a plane. She's going to start going slowly, and I'm the wind. Now, I'm pushing her. Right now, is she going due north anymore? So what could you do then? If I'm pushing you that way, how do you counteract that? You push back the other way, right? And if we balance those out, in order for you to go straight, what does that net force have to be? 0. Boom. Okay. We have, this is 0. Before we even calculate it out, this must be 0. Has to be. There's no other option because we have to end up due north. Okay. Now, with that said, we could set up Vy as well, but we still don't know that theta, right? Like that's part of what we're after. So, goodness. Any other equations? I like the Vx and the Vy. Those showed up in every single problem that we've done. Sean, you said something right off the bat earlier. What did you say? Pythagorean theorem. Now, whatever our plane winds up flying at, I know that Pythagorean theorem with our coordinates is going to work out. Everybody okay with that? Like, it has to. So if I want to, and I do in fact, if we look at the velocity of the plane relative to the ground squared, I know that this has to be what? According to my Pythagorean theorem. So I like what you're thinking. You're thinking the velocity of the plane with relative to the air squared. I'm good with it. Does our plane have velocity with components, theoretically? Like, I mean, not even theoretically. Can we always get components of how far horizontally and vertically are we going? What do you call the horizontal direction? And we use our shortcuts with writing it. How would you indicate how fast this is flying in the x direction? Vx? Plus what else? Vy squared. Okay, whether we use this right this second or not, I think that we have it, and even more so, gosh, something nice is going to happen, because what do we just determine that Vx was if we want to wind up due north? 0. Say that again. V sub x is still 0. This is our Pythagorean theorem. V sub x had better be 0 in the end now. Plane relative to the ground has to be 0, because I know that these guys, when they add up, they cancel each other to ensure that we fly due north. Okay, I use a little bit of substitution stuff when I work through this problem. I want to find the angle. That's what we're after. So let's see if we can't put all this stuff together. I want you guys, I'm going to give you one little substitution that I used, and I'm trying to decide, it's just to make notation a little bit nicer. How do we want, because I want you guys to do it, I don't just want to give you the answer. Okay, so we're going to keep kicking in. I'm going to give you a shove on where we plug in. I'm going to see how this unfolds. What do we know that this is in the end, Vx? And I know that it sounds like a broken record, but before we calculated it, I said, let's just think this out. It's 0, and I'll switch back to blue so they match. 0. Now, do we know the velocity of the plane relative to the air? $285. And I'm just plugging directly in here, but I wanted to make sure that we can think out all the equations that we might use, because if they're listed at the beginning, we're not going to lose them at the end. Okay, cosine of what is the new issue? And instead of me asking and just waiting like 30 seconds in silence each time, here's my challenge. I want to watch the game, first of all. Second thing, I want you guys to play around with this. If we can make a just verbal contract here that you guys are going to keep trying to evaluate this for a few minutes while the game is up here, I'm cool with it. I want you to roll with this. I plugged in the very, very, very first part of this, right? Cool. Keep rolling with it. We know that Vx is 0. See what else we can plug in, and if there's a possible way that we can solve for an angle. One little thing that I did, you do not have to do this, but it's just what I commonly do. Anybody else think you run the risk of getting confused with theta, whichever one you're talking about, because we have a bunch of them? If you are really good at writing stuff down and never losing track, that's awesome. I'm not really good at not losing track of stuff. One thing that I did that is entirely up to you, if you want to, we need to know the plane relative to the ground. Sorry, I just lost my train of thought. Yes. Okay, I let phi take the place of an angle just so I don't get confused as I'm writing it. So on mine, I have let phi equal theta of the plane relative to the ground. Cool. I will give you guys a few minutes. We'll get the game up here. Today's pretty chill. We're at the end of the chapter. I have some stuff that I think I'm going to send you, or an assignment that I'm going to send with you this weekend to look back over stuff. But because, just as a reminder, we did the first section like before the break, we're going to use Monday and Tuesday to study and prep and stuff, to continue studying and prepping. This is the hardest problem, I would argue, of probably the whole chapter. Not that there's anything super crazy about it, but it's a little bit more rearrangey. As long as you guys are working, we'll come back to the board here momentarily, but we're going to watch a game for a few minutes. Cool, cool? Cool. All right, try stuff. Don't be afraid to be wrong. If you're wrong, that's cool. We'll try again. It's not going to kill you. Awesome. Well, no, I am right now, though, because currently they're watching a video in which they're watching a video of themselves. And that's just a neat idea. But now I don't know where the pause button is. And, all right, we just watched the game, and the Lady Raiders have won. All right. Okay, so looking at this. Easy places to get goofed up. If you don't use the subscripts, as long as you don't get lost in your problem, I won't fault you for it. I think you should. I would if I were you, but if you don't, I understand it. Fern did not use subscripts when he did his work. He did not get lost through the problem. I've looked at somebody else's work who did. They tried to not use subscripts and stuff just as we're going, and you were plugging in the wrong stuff. So it is, if you're one of those people who, like, you get the equation, you start just plugging in the wrong things, we are going to rely on this being written in clear to really help us through this problem. 285 is the velocity of the plane relative to the air, right? Do we know the angle? Now, if we don't want to use subscripts, I'm cool with that because there's only going to be one unknown. If I don't know an angle, I called it phi. Do you guys want to call it just theta? Or do you want it? I'm cool with calling it theta, and we'll just see what happens. Cosine of theta. Okay, plus what else? What else is going in this x direction? So the plane's flying. What else is moving? The wind. And how fast is the wind moving? 95, and that's in the x direction. We'd say it's cosine of what angle? 30. Could we solve this for angle theta? Prove it. If you haven't done so yet, solve this for theta. Or if you're looking at it and going, oh, I don't know what the heck to do, let me know that, and we can do it. This is a variable that's stuck inside. Always with algebra, isolate it. I'm going to give you a second. Abigail, did you get a number for velocity yet? Okay.
I think I rounded a little bit too much, so the answer may be different, but 337.7.
We're off a little bit more than I would expect, but you're ballpark. Like, you've done the right stuff. The rounding is probably the issue. Okay. How do I solve this? Like, it looks ugly, and is that ugly to you guys? I don't know. Mickey, what would you do? We're trying to solve for this theta. How do you make it so only something with thetas on one side so far? Okay, and you would use actual numbers as you're doing it? You would use numbers. Okay, so let's do that. I'm fine with that. 285 times the cosine of theta, whatever it happens to be in the end, plus, I don't know what 95 cos 30 is, but I have a feeling 95 cos 30, is it 82.27? Okay. I had it written down just for the record. I did not do it in my head. Cool. That's a ballpark number, right? Like, we're rounding. That's okay. Still equal to what that I didn't put on the left side? That is correct. Cool. Now what? So Mickey hooked it up right away. If this is the route that we're going, which it's the route that I'm going on the board. Barseg, if I want to solve for theta, it's stuck inside of my cosine right now. I need only that on the side. What's your next algebra step? Okay. So negative 82.27 is equal to 285 cos theta. That's supposed to be an 8. All right, we still on the same page. Cool. Still trying to solve for theta. Kalisha, if I want only cosine theta over here, divide both sides by 285. Love it. Okay, I'm just going to cross it out to show a little bit of work. Now I have cosine of theta equals whatever that winds up being. Can I just divide by cos? No, cosine is not just a number. It's not an operator. It's a function. How do you undo cosine? Inverse cosine or arc cosine, whichever language you prefer. I'm going to switch sides because it feels more natural to have it on the left. Theta is equal to the arc cosine of negative 82.27 over 285. And what do we get for theta? 106. One more time. 0.77. Okay. We have the angle. Love it. What now? Do we want to keep it at that or do you want to make it a bearing? Okay, I'm fine with keeping it at that. That's good with me. Now, what else do we need? We have the angle. I'm good with it. We need the velocity. Well, shoot. How do we do that? And I'm not, so when I say that, I think that it seems, I can't tell. I'm not asking you to solve the whole problem for me. When I ask, like, how do we do it, I'm really just asking for suggestions. If we get a wrong one, that's cool, we'll deal with it. If we get a right one, even cooler, we'll deal with it. Like, same thing. No fear. I don't think that fear is the right word for everybody. Open to whatever. Fern, I haven't heard from you and we're making eye contact. What do you suggest we might do? Find Vy. Sure, let's try to find Vy. Okay, so here we go, Vy. Now I know that when we plug this in, it's just going to be those same pieces, right? Velocity to the plane relative to the air, sine of theta plane relative to the air, plus velocity of what? What else? Plane and air and something is going to make plane and ground. Air and ground times the sine of theta that the plane flies air to ground. Okay, we have some numbers. In fact, I think we have all these numbers. I think we just worked them all out. How fast is a plane flying relative to the air? 285 times the sine of what angle did we just find the plane was flying with? 106.77 degrees. Plus, what's the velocity of the air relative to the ground? 95 times sine of, what's that angle? It's 30, right? Cool. Well, that just looks like a plug and chug situation. And remember, we're getting y in this situation. Now, we've already determined early on that relative to the ground, the x direction was what? So whatever y is must just be everything. Cool. I rounded to the nearest 10. 320 is what I'm after. Can somebody second that? Cool. Do we know how fast a plane flies relative to the ground at this point? Do we know the angle at which it must fly at? That's exactly what we're asked to find. As we deal with these, one quick statement at the end, and I'm content with it. Plane flies. And I would like your guys' input on a better way to word this, because I use the word at twice every time I write these down, and it seems clunky. Plane flies, I like it. At what speed? 320 kilometers per hour. At what angle? I'm going to call it 107, just because no, I lied. I'm going to call it 106.77 degrees. Okay, do me a quick favor. I know that this is not our pre-calc class, but it's valid in here. Write this angle another way for me. Just an alternative way to write that angle. So I had a question mouthed out in the
West, north 16.7.
north. Do I start at north or do I start at west? So careful, and I'm
West 16.7.
if I start at north and I fall 16.7, I go here. I'm good with that. North, 16.7 degrees, west. Cool. Now, in a plane situation, I made this comment earlier. If you were a pilot, this wouldn't be presented like this. They would just tell you 16.7 degrees because in aviation, everything's from north. Okay. I'm not going to make us do that because it just makes it more messy. But if you're going to work for air traffic control at some point in your life, be prepared.
Which way to go?
Because you're always taking it from north if you're in a plane.
I know, but if they said 15 degrees, how do you know if it's 15 degrees right or left? They tell you.
Positive direction still applies.
Oh, yeah.
Yep. Or realistically, they would never tell you a negative. If they wanted you to fly at 15 degrees this way, they would say, hey, go ahead, breaker 9. I don't know, pilot talk well enough. They would tell you to fly at, what, 343 or I don't know the number, 3 whatever. They would subtract it from 360.
All the
Yep.
way-
They would give you this angle
Oh, okay.
all the way from north. Yep. Cool. All right. So we had a long chapter. There's one more idea, and again, I'll have the packet stuff for you guys in pre-calc, which feels like I'm cheating because that's not the physics class. Cool. One more thing that we need to talk about, and this is not related to relative velocities. Relative velocity stuff isn't crazy, but we have these things in physics that I hate the name of it. They're called fictitious forces. Okay, when you hear fictitious, what does it make you think of?
Fictional.
Fictional. What's fictional mean?
Not real.
Made up, not real. Okay, so this is really from 6.2, but we're going to hit it here really quickly because we don't need a ton of discussion on it. I just want to make sense of it, and it's a good review. If we're going on a circular path, something I have to be accelerating, right? Even at a constant velocity, I have to be accelerating. Do you guys remember what that acceleration is called? Centripetal. Okay, so in your notes, this is just a quick little follow-up, and I'm sorry I didn't hit it then, but we didn't have any problems regarding it. So 6.2, just a recall real quick, and you can add it in your section. It can be here as long as it's all in the chapter. I'm fine with it. Okay, centripetal acceleration toward the center of the circle is responsible, or I'm going to say leads to or implies, if we have acceleration and there's a mass that's being accelerated, mass and acceleration together make what? A force. Centripetal acceleration leads to centripetal force. Everybody okay with that? Acceleration and mass make a force. Centripetal acceleration and a mass make a centripetal force. Okay, there is another word that you guys have probably seen that it drives me crazy because I want to pronounce it the same, but I'm going to pronounce it like really obnoxiously. Centrifugal. Now, fugal. If I called it centrifugal, there's very clearly a place to get goofed up here. Okay, what's a centrifuge? And have you heard of a centrifuge? So my blood's made of a lot of stuff, specifically red blood cells, water, and plasma. There are very, very many applications for use of blood plasma, but you don't need all the red blood cells. How do you separate it? You spin it really, really, really fast in a centrifuge. That's an easy example of it. That carnival ride that you guys have all probably ridden in is a centrifuge. Okay, so we have this idea of a fictitious force, and I'm going to make, whoa. I'm purely using your guys' facial expressions to see if this word is spelled correctly. Does that say fictitious? Okay, fictitious forces. I'm pretty sure that's right. Okay, they're weird. If you imagine yourself on a merry-go-round and you're sitting there and it's not spinning crazy fast, what does it feel like to you? Does it feel like you're being pushed toward the middle, or does it feel like you're being pushed out? It feels like you're being pushed out, right? Now, and this is just a strange idea, from your perspective, you have to be balanced, right? Because something's pulling you in, but you're not getting sucked to the middle of it. Something must be fighting you back out. Now, there's nothing physically acting on you. There's no agent that causes that push back other than the fact that you're in a moving frame of reference. We'll continue later. I'll have a packet for you guys in pre-calc, depending on whether or not I decide if I think it's fair or not. Okay.
Not fair.
We'll see. If you have that worksheet done, I'll take it. If you don't, you need to finish it, and I'll take it. Nice job, Lady Raiders.